Okay, this is our pre-calculus chapter 2 test walkthrough. So again, if you feel like you only need a few of these problems, feel free to skip to whatever ones those are. Otherwise, here we go. So first ones here, we're going to be converting from radians to degrees and degrees to radians. So the equation which we have for this is radians over pi is equal to degrees over 180. Now that sets us up a nice ratio. So we're going to plug in the parts which we know, solve for what we don't know. So I'm going to have 50 over 180 equals my radians over pi. So all I really need to do here is reduce my fraction here. So I can reduce those down to 5/18, and that's as close as I'm going to be able to get it. So I'm going to have 5/18 equals r over pi. Then I just multiply both sides by pi to get r by itself, and I get 5 pi over 18 as my number of radians. So not too bad there. Going from radians to degrees, I'm going to do the same thing, but I'm going to plug this into my r and I'm going to solve for my d. So I'm going to have 11 pi over 12 over pi equals d over 180. So here, those pi's are going to cancel off immediately. So then I'm just left with 11 over 12 over 1, which the over 1 is going to do nothing to it. So it's really just the fraction of 11 twelfths. So multiplying both sides by 180 now, I can just take my 11 twelfths, multiply that by 180, and I get 165 for my number of degrees in that set. Okay, so number 3, 4, and 5, we're going to be using the idea that the wheel is rotating at 4 rotations per second. So that's going to be 4 rotations over 1 second. So this is going to be a lot of unit analysis type stuff here. So I'm trying to get it into radians per second. So I know that I want to leave seconds and I want to get rid of rotations. Well, I do know how many radians are in one rotation, because one full rotation is 1 circle, so that's 2 pi radians. So I'm going to put rotations on the bottom and radians on the top. So 1 rotation is equivalent to 2 pi radians. So this is 2 pi radians is the same as 1 rotation. So this is really the same thing on top and bottom of my fraction. So this becomes my giant 1. So when I multiply by that giant 1, my rotations are going to cancel out, and I'm left with the unit of radians per second. So that's 4 times 2 pi, which is going to be 8 pi over 1, doesn't do anything. So that is 8 pi radians per second. Right. Over here on number 4, we know that the diameter is 30 inches. So that means that my circumference, which is the diameter times pi, is just going to be 30 pi. So I still start off with knowing that I have 4 rotations per 1 second. And I'm ultimately trying to get into the unit of feet per second. Well, I don't have anything that is rotations to feet, but I do have rotations to inches, because this is 30 pi inches. So I can say, well, 1 rotation is 30 pi inches. I want to put the rotation on the bottom of that giant 1 because I need it to cancel out. So 1 rotation is equivalent to 30 pi inches. So here's this giant 1. So now when I multiply these, I'm going to get my rotations to cancel out. 4 times 30 pi is going to be 120 pi. Inches per 1 second. Well, now that I have this inches per second, I need feet per second. Well, I do know how many feet are in 1 inch. So I'm going to need to have 20 12 inches on the bottom is 1 foot on the top, and that's my new giant one. I'm kind of a little cramped on room here, but hopefully we get the idea, right? So here my inches cancel, so I'm going to have 120 pi times 1 foot over 1 second times 12, so that's going to be 120 pi over 12 feet per second, which I can reduce 120 pi over 12 into just 10 pi, because the 12s are going to reduce down, and I'll be left with that 10 on top. So that's going to be 10 pi feet per second. And there we go. So both of those are just about unit analysis and getting those giant ones and making sure, once again, that our units always cancel out, because otherwise it's really easy to get the tops and the bottoms of those mixed up. All right, so then number 5 here, we're trying to simplify this. So this is all about rules of exponents. So if I have x to the 4th raised to the 1/2, if I have a power raised to a power, I just end up multiplying those. So 4 times 1/2 is going to be 2, so that's going to be x squared. And then 6 times 1/3 is going to be 2, so that's going to be plus x squared. And if I have the same thing being added to itself, that's just 2 of those things, that is equivalent to 2x squareds. Right? So again, it's all about this rules of exponents there. All right, down here for number 6, we're going to try and list out all of our intervals of increase and decrease, and intervals of concave up and concave down. So increase, let's start there. I'm decreasing here down to here, then I'm increasing from this point to this point here. Now all of these intervals are done in x coordinates. We never want to use y's here. The only time you would ever use y's is if you're talking about range. Past that, it's always going to be x's, right? So from here to here, which is a -1 to 0 on my x's, that's an interval of increase. So from -1 to 0. Then I'm also increasing from +1 to forever. So that's going to be also from +1 to infinity. So those are my 2 intervals of increase. We can technically put the big giant U there for a union, but we haven't really gone over that much yet, so don't worry about it. My intervals of decrease, well, that's going to be from -infinity all the way down till here, which is going to be -infinity till -1. And then I'm also decreasing from 0 to 1 here under that interval. And those are my 2 intervals of decrease. Okay. So then if we're talking about concavity, if we concave up, that's whenever I have my kind of bowl shape versus my mountain shape, right? So we can think of it as kind of, I definitely have a bowl here, but then where does the bowl turn into the mountain? We kind of assume it's going to be halfway, right? Now it's not always, but for right now, that's an easy way for us to kind of estimate or guess it. We will figure out how to find that exactly in a calculus level class. So I'm going to be, well, I'm concave up from -infinity all the way over here till a -1/2. Or -0.5 if we want to use decimals. And then I'm also concave up from 0.5 up to +infinity. So there to there, concave up, there to there, concave up. Now my only place where I'm concave down is here to here, which is from -0.5 to +0.5. So again, the biggest error that I always see on these problems is people trying to like list out points And I think they get that because they say, oh, look, these look like points. Those are not points. Those are intervals in that interval notation we've been trying to use here, right? So you can also kind of check these by saying, well, everything should be taken up at somewhere here other than those points where it's actually going to be changing. So I'm increasing from -1 to, sorry, I'm decreasing from negative infinity till -1. Then from -1 till 0, I'm increasing. Then 0 to 1, I'm decreasing. Then 1 to infinity, I'm increasing A again. So everything is covered there, right? There's no gaps, there's no overlaps, there's no stuff like that, right? That same thing should happen here for my concavity. I'm up from -infinity till -0.5. Then from -0.5 to positive 0.5, I'm down, and then from positive 0.5 to infinity, I'm back to being up. So again, there's no gaps there, and there's no overlaps. Then down here on number 7, we're trying to determine, is this function even, odd, or is it neither? So you can sketch out graphs of these. And that's kind of a easy way to do it, or you can do it the algebraic way. If I do a graph, I would say, well, this would look like a parabola being shifted to the right 2. So it would look something like that, right? Now from that graph, it's fairly easy for me to tell even, odd versus neither, right? If it's even, it would be symmetric over my y-axis, which this is clearly not. If it's odd, a vertical reflection, which would give me this, would be the same as a horizontal reflection, which would give me this. Those give me two different things, so it's not odd, so it's going to be neither. So graphically, I could do that. But well, what if I can't do it graphically? What if I don't know how to graph this, right? Well, that's when we got to do our little test here. If it's even, then f of x is equivalent to f of negative x. That's even. And if we're odd, then f of negative x is equivalent to negative f of x. That would be odd. So I already have f of x. Let's find f of negative x. So f of negative x is equal to, this would be a negative x minus 2 squared. I could multiply that out, but I know that this is going to give me a different answer than this would, so they're not equivalent there. And then I also would do for the negative f of x, that would be negative and then x minus 2 squared. So that one, again, I can't just bring that negative through because it's being raised to the second power. If you need to, you can FOIL that out, and FOIL that out, but you're going to get different things because this negative here, and negative, and no negatives. All three of those are different. There's no correlation there, so it's going to be neither. So there is either check it graphically or you can do it algebraically if you're not sure how to graph that particular one. Okay, so onto the back page here. Make sure this is visible for us. So we're going to be trying to take this graph here. So this is our graph of f of x. So I'm trying to make sure that, hey, do you know how these transformations work regardless of the actual function? So if we do this minus 1 means I'm going to be going right 1, and then this plus 3 means up 3. So every single point here, if I look at these as kind of important points to shift from, every single one of those points is going to go to the right 1 and then up 3. So this one would go right 1 and up 3. So I would be at negative 3, positive 4. There's that point. This one would go right 1 and then up 3. So it's going to be at negative 1, positive 2. Then here we're going right 1 and then up 3. So it's going to be positive 2, positive 2. And then over here we're going right 1 and then up 3. So this is going to be at 5, 6. And I can just draw my lines between those. And there we go. So doing with shifts, it's a little easier just to deal with each point individually. So then here on problem 9, we're going to take that same graph, and this 2 on the outside means I'm going to double every y value. It's being vertically stretched by 2. So every y value is now being doubled. So here, where it was at negative 4, 1, now it's going to be at negative 4, 2. And here, where I was at negative 2, negative 1, now I'm at negative 2, negative 2. Here, where I was at 2, negative 1, now I'm at 2, negative 2. I just realized that this one here was off by 1. Yeah, I think all of these. No, I'm good. I'm good. I'm good. Okay. Or did I draw that over? I think this should be over one more, shouldn't it? There we go. Sorry. That's on me. So disregard that one. All right. So it just looked off, so I noticed it. Anywho, here, this was at the 0.43, so that's going to be at the 0.46. I'll draw my line between all of those. There's my graph, like that. So again, doesn't need to be perfect, but try and get those points as close to where they should be at as possible. I've designed these so that they should all be at nice, pretty numbers. You're not going to be getting weird fractions and decimals and things like that. Okay, so now we're trying to find some coterminal angles. So negative 5 pi over 6. So definitely have your unit circle in your notes. If you don't have one, get one as soon as possible. You can just Google unit circle chart or unit circle graph, and you'll get these kind of images all over it. So I'm looking for a negative 5 pi over 6. Well, positive 5 pi over 6 is this angle here, right? So I want that distance, but in the negative direction. That would put me right here, which is going to be equivalent to 7 pi over 6. Now there is an infinite number of other angles that are equivalent to that, but in general we want to try and give the one that is on this unit circle be between 0 and 2 pi. So 7 pi over 6 is where I'm going to go there. And technically you could go the other way and keep going negative one more rotation and get another equivalent there, but in general try and go for the one that is positive and in the first unit circle there, or the first circle. All right, now we're going to try and find the exact value of the tangent of 8 pi over 3. Well, 8 pi over 3 is not on my unit circle, right? So 8 pi over 3, well, to get one full circle is 2 pi, which is 6 pi over 3. So if I've gotten 6 pi over 3, I have 2 pi over 3 remaining, meaning that I can go all the way over to here. So 8 pi over 3 is equivalent to 2 pi over 3. So if I find the tangent of 2 pi over 3, then I have it. So if I look there, we don't get down my chart, 2 pi over 3, my tangent is negative rad 3. Done. Okay, so that's all of these are our, hey, can you find coterminal angles, specifically the ones on that unit circle? And then from there, can we find sine, cosine, or tangent of that particular angle? So do you have that chart and know how to use it? Okay, so then number 12 here, we're going to be trying to find the equation of a line that gives us this particular graph. So first thing that I want to do is look at what I want a cosine graph. So that means that it's going to have been shifted somewhat, because cosine will start at a peak, and this one is clearly starting at the midline. So this is really a sine curve. So I'm going to have to shift it to get that cosine curve out of it. Other things that I notice, if I have my midline, if I draw that in, it's right here. My amplitude, this distance here, is 1. So that means that my A is going to be 1, which seems pretty easy for me there. I have a shift this far, because it is cosine. So I got shifted to the right that pi over 2. And then my period, well, looking from start to finish, my period is 2 pi. So that's the base period, so I don't really need to worry about things as far as that goes. But I do have that vertical shift of 1. So I have a horizontal shift and a vertical shift, but I have no vertical compression or expansion, no amplitude change, and I have no horizontal expansion or compression, which would be a period change. So it's going to be a cosine graph that has been shifted to the right pi over 2, so x minus pi over 2. And I've been shifted up 1, so plus 1 on the end. And there is my equation for that particular graph. And that is it for the Chapter 2 test. So with that, good luck.